Hey Physical Science, welcome to my video on velocity and acceleration. So let's quickly go over the definition of velocity before we start. Okay, it's the speed and the direction at which an object travels. So in this class, we're going to be using the terms velocity and speed pretty interchangeably, but please note that velocity does include direction. So for example, if you are traveling 60 miles per hour north, 60 miles per hour would be your speed, north would be your direction, and altogether that is your velocity. Velocity or speed, that's right, how far an object moves in a very specific amount of time. So you can see that in the examples of units that are on the screen. Meters per second. How many meters do you move every second? Or miles per hour. How many miles do you move in an hour? Those are the most common units that we'll be using, but you can also speak about speed or velocity in terms of minutes or inches or yards, right? So for example, I swim at a rate of, half a yard per second, or a caterpillar moves at about a speed of 2 inches per minute. You always will have a distance, and then you will have a time in which you go that specific distance. Okay, so when we are calculating velocity, we use the equation velocity equals distance divided by time. In online class this week, I gave you the opportunity to take a guess as to what you think my 100-meter dash time would be. So before I show you what went down on the track today, go ahead and take a look at everyone's guesses.
Of course, the win will mean that it won't count, but this has been a great year for her. It cannot be. No one can run that fast. The heat here must be doing something to the electronics, but she won by such a margin. She worked 2 jobs this year, earlier in the year.
So the question I pose to you is, how did my performance measure up to the athletes that will be mentioned in the rest of this video? And your task is to find my velocity and write it down as the answer to the first question on your online assignment. So AJ and Blizzy are pretty much Olympic athletes compared to me, so let's analyze their best times. AJ's average velocity during his best 100-meter race was 8.85 meters per second. What is his personal record? So how long did it take him to run that race is the question. So let's write the equation first off. Sorry for the bad handwriting. It's really difficult to write on tablets for me. So we've got velocity equals distance divided by time. Now let's remember that circle diagram that we used earlier in the semester to do density. I'm going to draw that for you guys. Remember I said that we can use this diagram for any equation in this class. Now, again, if you are comfortable using algebra and plugging in the variables and solving for the missing variable, by all means, go ahead and do that. If not, this is how we're going to go through these problems. So remember that when you're looking at the equation itself, you're going to plug that in to the diagram just as it's written. So in the equation, your distance is on top of your time. So in this diagram, your distance is also going to be on top of time. So distance on top of time, and then in that other blank you'll put velocity. Okay, so let's plug in our numbers then. I'll draw another one right here. Oops. Here we go. Okay, so what is our distance? How far is AJ running? Well, you have 2 numbers here. You have 100 meters and you have 8.85 meters per second. Which one of those is distance? Well, meters. So let's put 100 in for the distance. And then let's put 8.85 in for velocity. Now I know that's velocity because it's meters per second, right? We've got a distance and we have a time. So I'm going to put 8.85 in here. And we don't know the time. That's what I'm asking you. How long did it take him to run this 100 meters? So then let's go ahead and do this math. Remember that you always take the top and divide it by the bottom. So we have 100 meters divided by 8.85 meters per second. And that gives us 11.3 seconds. Okay, so now let's look at one of Blizzy's races. So he runs the 200-meter event in 24.3 seconds. What is his velocity during the race? So I will write the equation for you again. We've got velocity equals distance divided by time. I will draw this circle diagram for you. Distance is on top, time is on the bottom, velocity is in the other blank. Okay, now let's plug in our numbers. So the distance here is going to be 200 meters. That's how far he runs. And the time it takes him to do that is 24.3 seconds, so that's time. So I'll put 24.3 in here. I want to know what the velocity is. And again, this is division. So we'll take the number on the top divided by the number on the bottom. So 200 divided by 24.3. And I did not calculate this beforehand, so let me do that. Take out a calculator. 200 divided by 24.3 is 8.23 meters per second. Great, so that is how fast he's running for a 200. That is very fast for a 200. Props to Blizzy. And also props to AJ, because that 100 time is like outstanding. Now let's take a look at actual Olympian speeds. The fastest human running speed ever recorded was 12.4 meters per second by Usain Bolt, which, just so you know, is about 28 miles per hour, which is incredibly fast. He was able to hold this velocity for 3.7 seconds. How far did he run in this time? So within those 3.7 seconds, how far did he go? So let's complete this circle diagram with your distance on top, time on the bottom, and then velocity here. And then let's plug in those numbers. Distance on top. Do we have distance? No, it's asking for distance. How far did he run? That's distance. So we do not know the distance. Now, velocity is 12.4. That's how fast he was going. And then he was able to hold that speed for 3.7 seconds. 3.7 seconds, that's our time. Okay, so what do we do then to find distance? Remember that if they are next to each other, on the bottom of the circle diagram, you always multiply. So we're going to multiply distance equals 12.4 times 3.7. I gotta get a calculator for this one again. 12.4 times 3.7 is 45.88. 45.88. Now, what are the units? Well, you know this is going to be distance, so you know it's some sort of length. Now, I'm going to look at the units that we used for velocity to be able to determine the units for distance. We use meters per second for velocity. So we're going to record our distance in meters since that's what we used in velocity. So 45.88 meters.